In our last lesson, we worked on adding and subtracting rationals that already had a common denominator. So in just a little bit, we're going to add and subtract rationals that don't already have a common denominator. So we're going to have to know how to turn them into a common denominator. This lesson is on finding that denominator. So remember, when finding the denominator, we're looking for the least common denominator, meaning we're trying to make it as small and simple as possible so that it's less complex and less difficult to work out. So for instance, if I were trying to find the common denominator between 6 minus 2w and 9 minus 3w, the easiest way to do that is to find all of the factors. So I would break this into 2 times 3 minus w and this into 3 times 3 minus w, because that shows me that I already have a 3 minus w in common. What I don't have in common is the 2 and the 3. So we can see that the least common denominator would have to include both the 2 and the 3 and a 3 minus w. So include all of that. So 2 and 3 minus w multiplies into 6 times 3 minus w. I would not distribute that back out, so we're going to keep everything factored. So step 1, factor each. Step 2, it's the product of each prime factor, so every factor that you have, the greatest number of times that it appears in any factorization. That's what we're looking for. So we're factoring and then writing the greatest number of times it happens in one fraction. Let's take a look. 16x squared y to the third. 16 breaks down into, if I made my factor tree, that would be 4 times 4, 2 times 2, 2 times 2, etc. That's where I get that 2 to the fourth, and then x to the second, y to the third. 56, same idea. I would break it down into my tree. It would be 2 to the third times 7 times 1x times 4y's. Once you have everything factored, then I'm looking for the greatest number of times that it's repeated in just one factorization, just one term. So if I'm looking at my 2's, it happens 4 times here and 3 times here, so the most number of times is 4. Looking at my 7's, it happens 0 times here and 1 time here, so the most number of times is once. Looking at my x's, 2 times here, only once here, so 2 times is the most. And then 3y's and 4y's, so 4y's is the most. So notice my LCD is all of those things. 2 to the fourth and 7 and x squared and y to the fourth, which gives me 112 x squared y to the fourth. Again, we're still not adding or subtracting. We are just finding the LCD, so I'm going to factor only the denominators. I could care less right now what's happening on the numerators, not until I start adding and subtracting. So factoring this, I would look for numbers that multiplied to 20 that added to 9, which would be 4 and 5, positive 4, positive 5. Factoring my other one, I'm looking for numbers that multiply to 16 that add to 8, which of course would be 4 and 4. Now, to find the LCD, I would take the most number of times that each factor occurred. So see how I have x plus 4 once and x plus 4 twice. So the most number of times it happens is twice. And you can either write it twice or write it with a squared. And then I've got my x plus 5, which happens once and no times. So the most number of times is once. So this is my LCD. Do not multiply it out, because you're just going to make a giant headache for yourself, and we really don't want it multiplied out anyway. These are 2 for you to try on your own, so try them both, then press play to see how you did. For my first, I would factor into x plus 2, x plus 2. Again, I don't care about the numerators right now. This would factor into x plus 2, x minus 3. So my LCD would be x plus 2 twice. I'm sort of ignoring this one because it only happened once here. And then x minus 3 once because it happened once here. For my second, this is one of those tricky ones where they're almost the same thing. 7 minus z, z minus 7. I would probably rewrite this as -1, z minus 7. And now I can see that my LCD would be -1 because it happens once here, and z minus 7 because it happens once here and once here, so the most number of times is once.